A very good morning to all of you. I'm Dr. Nitin Mittal, working as assistant professor in Shri Vishwakarma Skill University. Today we will discuss the topic Introduction to Probability Theory. After the completion of this course, you should be able to know about the probability and probability theory, and more precisely, the basics of probability theory, the classification of sample space, the algebra of events. So let us start with the introduction to probability theory. The probability theory, it is a concept of the mathematical model that is used to describe a class of signals. There are two types of signals. The first one is the deterministic signal and another one is a random signal. The behavior as well as processing of deterministic signals can be determined with the help of mathematical model, which means that we can define such kind of signals with some mathematical modeling and we can predict it as well in advance. There are another class of signals whose behavior cannot be predicted, and these are called the random signals, and such kind of signals cannot be modeled mathematically. So probability theory is an essential mathematical tool in the analysis of random signals. So the question arises why there is the randomness. So random nature of the generation mechanism is there that causes the randomization. So limited understanding of the signal dynamics, inherent imprecision in measurements and observations. One of the example of such randomization is the thermal noise. It arises because of the random motion of electrons in the electronic devices. Another example we can consider for the weather prediction. So because there are certain factors that affect the weather, so we cannot predict in advance. So there is some randomization. Another examples include the temperature or rainfall in a place. So probabilistic models are established from the observation of a random phenomenon. So while probability is concerned with the analysis of the random phenomenon, so statistical is the tool that is used in such kind of modeling of the data. Now, let us start with the probability theory. Probability theory, as we already discussed, it is concerned with the study of the random signals or the study of the random phenomena. And such phenomena are characterized by the fact that their future behavior cannot be predicted in advance, as in case of the deterministic signals. So now let us start with the definition of an experiment. A random experiment is an action or a process that leads to one of the several possible outcomes. Now consider few examples. Now if we have one experiment, let us say tossing of a coin. So if we toss a coin, there may be two possibilities, head or tail. So the experimental outcome, it may come in the form of either head or tail. So there are two possible outcomes, and out of which one of the possible outcome may lead to some outcome. So if we roll a die, so there may be certain possibilities, it may vary from 1 to 6. Similarly, while playing a cricket game, there may be three options. There may be a win, lose or tie a match. In case of test cricket, there may be a draw, also possible. So next example is conduct a sales call. So in this case, the outcome may be in the form of whether the purchase is done or no purchase is there. So, and while discussing the experiment is an action or a process that leads to one of the several possible outcomes. So now, experiment, it is defined as the process which is conducted to get some fruitful results. If the same experiment is performed several times repeatedly under the given same condition, then similar kind of results are expected. An experiment is sometimes called another name, trial. So if we consider the case of throwing of a coin, then we may have two possible outcomes. It may be either head or tail. Similarly, rolling a die, we have 6 possible outcomes and so on. So possibility of this outcome can be predicted with the help of probability theory. As we already discussed, the probability theory is related to the randomization. Here, in the case of rolling of a die, throwing a coin, so there is a possibility that either head or tail may come. Rolling a die, there may be the possibility that 1 to 6, either of the outcome may occur. So it is related to randomization. So it is the part of probability theory. Now, an important term in the experiment is sample space. Sample space, the set of all possible outcomes of a random experiment, it is called the sample space. Now again, consider the example of tossing of a coin. So the possible outcomes are head and tail. So sample space is the collection of head and tail. It is called the sample space. So S is H comma T, where H signifies the head and T signifies tail. So if there are 3 coins that are tossed simultaneously, then the number of outcomes will be 2 raised to power 3. That means 8. So now sample space will cover all the possibilities because the coin is now thrown or tossed 3 times. So there are 2 raised to power 3 combinations, and the combinations may be all heads, all tails, 2 heads, 2 tails, 1 head, 2 tails, 2 head, 1 tail, and so on. So all the possible combinations are there. So we can write all the possible outcomes as the sample space. So S is equal to head, 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 tail, and so on, tail, tail, tail. So similarly, the case of rolling of a die. So S sample space is equal to 1, 2, 3, 4, 5 up to 6. So now another thing is, now consider, if we consider that we flip the coin 2 times, so sample space will be 2 raised to power 2 is equal to number of elements 4. So S is equal to head, 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 tail, tail, head, and tail, tail. Similarly, now another important term is the number of elements, and it is represented by N of S. So number of elements are the number of elements that are included in the sample space. It is called the number of elements. So maximum number of outcomes while throwing a coin twice is 4. Head, 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 tail, tail, head, and tail, tail. So this is about the sample space. Now there are few important properties of sample space. Now if we consider the case of a list of exhaustive and mutually exclusive outcome, and it is represented by sample space S, and these are represented by S is equal to outcome 1, outcome 2 up to outcome K. So given the sample space S is equal to O1, O2 up to AK, the probabilities assigned to the outcome must satisfy 2 conditions. The first condition is that probability of any outcome lies between 0 and 1. So this is the basic property of probability, that probability always lies between 0 and 1. And second important property is that the sum of all the probabilities is equal to 1. That means probability of O1 plus probability of outcome 2 and so on, probability of outcome A is equal to 1. So these are the properties of sample space that is related to the probability of the properties of your probability. Now next is the event. Event is the collection of a certain sample points, that is the subset of the sample space. It is called the event. So sample space considers all the elements in the sample space. So all the possible outcomes of certain experiment, it is called the sample space, and event is in which we are interested. Okay, so it is the subset of your sample space, and it is represented by capital E. Let E be the event defined on the sample space S. So E is now the subset of S. Let the outcome of a specific trial is denoted by small s, which is one of the element of S. Then if we consider that the experiment of throwing of a die, and the sample space, we know sample space is all possible outcomes. So S is equal to 0, 1, S is equal to 1, 2 up to 6. So if we want the outcome to be an even number, because we are interested in some particular outcome. This is called the event. So if we want the outcome of the throwing of a die is an even number, then the subset of this sample space, it is called the event, and it is represented by E is equal to set of 2, 4 and 6. So this is called the event. That means the outcome in which we are interested, it is called the event. So similarly, the sample space of flipping a coin twice is S is equal to head head, head tail, tail head and tail tail. For flipping a coin twice and the outcomes are different, so it is now an event. E is equal to head tail and tail head, because we are interested in the two outcomes should be different. So there are few important characteristics. If the event E has only one outcome, then it is called the elementary event. If the event does not contain any outcome, that means E is equal to null or phi, then it is called the null event. If E is equal to S, that means all the elements of sample space are there in the event, then it is called the universal or certain event. Similarly, now another important topic here is the algebra of events. Now, if we consider that there are two different events, event A and B, and both these events are the subset of sample space S, then we have the following important properties. Now consider that an example of throwing of a cubic die, we have the sample space S, which is equal to 1, 2 up to 6, and A is equal to, let us say it is 1, 2 and 4. Then the first property is complement. Complement is equal to all the elements of A that are not present in A is A bar. So A bar is equal to all the elements of X except A, that is 3, 5 and 6. So these are called the complement of event A. A complement or A bar is the complement of event A. Now again, now second is if S is equal to 1, 2, 3, 4, 5 and 6, and A is equal to 1, 3, 4 and B is equal to 2, 3 and 5. Now if we take A union B means we have to consider all the elements of A and B, but only once, not repeatedly. Then we get 1, 2, 3, 4 and 5, and this is called the union of events A and B. All the elements of A and B, which is considered here, but not twice. This is called the union of event A and B. Next is the intersection of event A and B. It is denoted by A intersection B. Then it is the event containing the elements that are in both event A and B, the common terms. So A intersection B is 1, 3, 4, intersection 2, 3 and 5. So we have to look for which event is common. So 3 is the event that is common in between them. So intersection of event A and B, it is called the A intersection B. Now the event containing no sample point in common, it is called the null event, and it is represented by A is equal to empty brackets or null or phi. Thus phi corresponding to an impossible event. Now consider another example. Let A be the event that the outcome of throwing a die is an even number. Then we get A is equal to 2, 4 and 6, and B be the event that the outcome be an odd number. Then we have B is equal to 1, 3 and 5. So A intersection B is phi or null, because there is no common element in between. So the events A and B are then called the mutually exclusive event, because A intersection B is equal to phi here. So the summary of today's classes, we have discussed about the introduction to probability theory, what is the significance of sample space, events and algebra of events in the probability theory. So these are the references. Thank you all for your patience learning.